Now it's time to talk about control flow, of which there are two forms. Conditional control flow, where you go somewhere if a condition is met, which is, for instance, if statements or if-elses. Also switches and loops, where it decides whether it's going to continue in the loop or exit the loop based on some condition. There's also unconditional control flow, where it always goes somewhere no matter what. This is, for instance, function calls like we saw before, and the goto statement in C, or exceptions and interrupts, which are not going to be things that we're going to cover in this class, but we will cover in a future class. So we've already seen that function calls for unconditional control flow turn into call ret instructions. So let's go ahead and see how goto manifests. Here's our goto example. You can see it's very simple. Basically, you get into main and it immediately goes to my label and it prints out goto for the win. So clearly the skipped portion is never ever going to be executed. And what does that look like in the assembly? Well, that introduces a new assembly instruction, jump, which we'll learn about next. Jump will unconditionally change the RIP, the instruction pointer, to a given address. And how do you specify the given address? Well, there's multiple ways. There's a short relative addressing form where RIP is going to be RIP of the next instruction. So it's not math based on the current instruction RIP, but instead the next instruction or the location after this instruction. RIP equals the next instruction plus 1 byte sign extended 64-bit displacement. So this basically just means 1 byte, which can be positive or negative, and it's going to be sign extended when you're doing the actual math on the 64-bit register. The most common place where you'll see a short relative jump would be, for instance, small loops, where it's just going to be jumping a small amount of assembly instructions backwards. We're not going to see it in Visual Studio, but some disassemblers will indicate in the mnemonic, instead of just saying jump, they'll say jump short, jump far, jump near, whatever the different form of it is. Also, FYI, since this jump short can be generated with a very small number of bytes, if you actually say jump -2, because the jump -2 instruction is 2 bytes long, and because the displacement is relative to the next instruction, jump -2 will just infinite loop continuously jumping back to itself. And we'll talk about this more later when we actually show the bytes that encode assembly instructions. But even though you'll see in Visual Studio jump and then some really long 64-bit address, the reality is this assembly instruction is not encoded with that 64-bit address baked into it. Instead, it's actually saying, 2 bytes, 1 byte to say I'm a jump, and 1 byte to say, and I want to jump C bytes forward from the next instruction address. Another way the given address for a jump can be specified is the far absolute indirect form, but we're going to completely skip this. That's much better covered in a future class because it depends on things like segment registers, which we don't know about. Instead, behind the scenes, these are going to be the common forms that are used for jump. Jump near relative, so instead of short relative, it's near relative, and the difference is it's a 4-byte displacement instead of 1 byte, so you can obviously jump much further. It's again a signed displacement, and it's sign extended because you're doing math on a 64-bit register. So basically you can jump 2 billion bytes forward, 2 billion bytes backwards. And then there's the near absolute indirect form. In this case, it'll have a RM64 or an RMX form, which is going to basically say it could jump to a specific address in a register. It could go pluck a address out of memory based on an RMX form. And either way, that's how you're going to get the address of where it should be jumping to next. So now you can go ahead and stop and walk through the assembly and make sure that you get that the jump is just jumping to where it's told to jump.